Hello learner, my name is Dickens and we are talking about salts, and in today's lesson we want to look at methods of preparing salts. I want us to start by knowing what are these methods of preparing salts. There are about 5 methods of preparing salts, so let us start by mentioning them. Method number 1, you can prepare a salt by the reaction between an acid and a metal. If you react an acid and a metal, you'll get a salt and hydrogen gas. Method number 2 of preparing salts is a reaction between an acid and metal oxide. That will still give you a salt. You'll get a salt and water. Our third method of preparing salts is reaction between an acid and metal hydroxide. If you react an acid and a metal hydroxide, you'll get a salt and water. Method number 4 is reaction between an acid and a carbonate, metal carbonate, or you can still use hydrogen carbonate. Hydrogen carbonate. Then lastly, method number 5 of preparing salts, we call it direct synthesis. Direct synthesis. So these are the 5 main methods of preparing salts. So we are going to start with method number 1, and that is reaction between an acid and a metal. So method number 1, reaction between an acid and a metal. Reaction between an acid and a metal. Reaction between an acid and a metal. So that's our first method of preparing salts. We shall do that by focusing on one specific example, and then we shall give other examples using chemical equations. So we focus on preparation of zinc sulfate. Preparation of zinc sulfate. This will give us a foundation, and then from there we can be able to look at other examples of the same using chemical equations. So how do you prepare zinc sulfate? This is our procedure. Number 1 is you measure about 20 centimeters cubed of dilute sulfuric acid and put in a beaker. You measure, of course, using a measuring cylinder. Then secondly, add zinc powder to the acid as you stir. So the reason for stirring is simply to allow enough time of reaction between the acid and the zinc metal. Thirdly, continue adding zinc powder until it is in excess. So we are using excess zinc simply to make sure that all the acid has reacted. That's why we are saying we add more and more zinc until all the acid has been used up. Remember, the reaction that is taking place here is the reaction between zinc powder and dilute sulfuric acid. Fourth, you filter the resulting mixture and transfer the filtrate into an evaporating dish. So we are carrying out filtration. Remember, in the procedure, the third point we have said, we are using excess zinc. So some of the zinc will remain unreacted. So how do you remove the unreacted zinc? By simply carrying out filtration. So we filter to remove unreacted zinc or to remove excess zinc. After which you will get a filtrate, and that filtrate, remember, the reaction is between zinc and sulfuric acid. So the reaction takes place, we shall get zinc sulfate and some hydrogen gas. So the solution that we'll get will be the filtrate, and the filtrate is actually zinc sulfate. So that filtrate is the one that will transfer into an evaporating dish. And once we mention evaporating dish, it means we are supposed to heat. So our fifth point is evaporate the filtrate to saturation. So saturation means the point at which this solution will be able is now ready to form crystals. That's the point we are calling up to saturation. So we have said, how do you tell that the salt is ready to form crystals? We said you simply take a clean glass rod and then you dip into that evaporating dish containing the filtrate. After that, you remove it and then hold it in the air, then allow it to cool. You observe the glass rod. Once you see crystals on the glass rod, it means the solution is ready to form crystals. After which you now remove it from the source of heat and then you allow it to cool. So that is our sixth point, that allow the saturated solution to cool. We have said this solution is said to be saturated simply because it's now ready to form crystals. So this is how our setup will look like. Initially, we are going to have our first beaker. The beaker here contains a mixture of sulfuric acid and zinc. It contains a mixture of sulfuric acid and zinc. So here we shall put a mixture of, this is our beaker. So this beaker, inside it, we have zinc powder, and then we have our sulfuric acid. So that's what we mix in the beaker. And then after mixing, remember we have said we are using excess zinc. We are saying that some of the zinc will remain unreacted, and we have said, how do you remove the unreacted zinc? By simply carrying out filtration. So during filtration, we need a filter paper. We also need a filter funnel. So this is how you should have your apparatus looking like. So in the second diagram, we are carrying out filtration as follows. So we shall have our beaker. We need another container that will carry the filtrate. And then here we shall have our filter funnel like that. And then here we shall have a mixture of the whatever we shall obtain in the first diagram here. That's what we shall transfer into the filtration part. So this will be our filter funnel. filter funnel. Then this is where we shall collect our filtrate. So the filtrate will be collected here. Remember, we have said from the procedure, we are carrying out filtration to remove excess or unreacted zinc. So the unreacted zinc will be left here in this filter funnel. Of course, it's going to remain on the filter paper that we are using. So that's how we shall separate the filtrate from the unreacted zinc. So after which, you now transfer this filtrate onto an evaporating dish and carry out evaporation. So we shall need our source of heat, the usual one. We have a stand, we have a tripod stand, then we have the source of heat. So this is the source of heat, and then we shall put our evaporating dish here. Then the evaporating dish will contain the filtrate, and remember, the filtrate is a zinc sulfate solution coming as a result of reaction between zinc and sulfuric acid. Of course, don't forget, we are going to have our wire gauge here, because just to hold that evaporating dish in position. So this is our filtrate there. Then this is our evaporating dish, like that. So we carry out evaporation. Remember, we have said, as you carry out evaporation, you should take note when the solution is ready to form crystals. And how do you know that? By simply dipping a clean glass rod into this saturated solution, and then you hold it in the air and then allow it to cool. Once it cools, you observe the glass rod. You'll see crystals on the glass rod. That means the solution is now ready to form crystals. Then after that, you remove it from the source of heat, and then you allow the salt solution to cool. After cooling, it will form zinc sulfate crystals. So we are saying we have prepared zinc sulfate by actually carrying out a reaction between zinc metal. So this will be the reaction, Lana, this will be the reaction. So the reaction will be as follows. Remember, in this beaker, we are having zinc combining with sulfuric acid. So when you're writing an equation, take note of the state symbols. They are very important. So this will give you which products. So our products will be zinc sulfate, which will be in solution form. That's why we are having it as a filtrate. So the salt formed here will be in form of solution. That's why we are putting aqueous and then plus hydrogen gas. So that is in essence the reaction that is taking place in this beaker here. Reaction is between zinc and sulfuric acid. We get zinc sulfate and hydrogen gas. So the zinc sulfate is the filter that we are having here. Now that we want to obtain solid zinc sulfate, then you have to carry out evaporation. Once you evaporate, you'll drive out the water, and then you'll be left with the zinc sulfate crystal. So this is one method of preparing salts, by carrying out a reaction between a metal, which is zinc, and a dilute acid, which is sulfuric acid. So we need to know this, Lana, that we have other salts which are prepared, which can be prepared by this method. So let's mention just a few. We have quite a number, but we can mention a few. So other salts are prepared by this method. They include the following. They include We have zinc nitrate, zinc nitrate. We have zinc nitrate. We also have zinc chloride. We have zinc chloride. We have lead nitrate. We have lead nitrate. We can still have lead chloride, and so on and so forth. They're quite a number. These are just a few where we're reacting a metal and an acid. So having said that, let us see in form of an equation how can we prepare these salts that I've mentioned here. We want to see it using an equation. Remember, equations are very important as far as examinations are concerned. So we want to write using an equation how zinc nitrate is prepared. From the name zinc nitrate, it means you can be able to tell the acid we are using. So from the word nitrate, it means we are using nitric acid. From the word chloride, it means we are using hydrochloric acid. From the word nitrate, once again, we are using nitric acid, and then here we are using hydrochloric acid. So let us see in terms of equations, how do you prepare zinc nitrate? So zinc nitrate is prepared by reaction between zinc and nitric acid. So zinc and nitric acid, the procedure is the same. You take the acid, you put in a beaker, and then you add zinc powder until it is in excess. You'll get a salt, and that salt is called zinc nitrate. Zinc nitrate, that's how we write zinc nitrate, plus hydrogen gas. Zinc nitrate plus hydrogen gas. So anytime you write an equation, always remember to balance. So this equation of ours is not balanced. We have to balance it. As you can see, we have 1 atom of zinc on the left and 1 atom of zinc on the right. That means zinc is balanced. Next, you check hydrogen. I'm having 1 atom of hydrogen on the left-hand side of the equation. This side has 2. So I have to make sure there are 2 on both sides. So I have to put here, I multiply this part by 2. So that will mean I'll have 2 atoms of hydrogen on the left and then 2 atoms of hydrogen on the right. Then nitrogen atoms, I'm having 2 atoms of nitrogen. I'm also having 2 atoms of nitrogen on the right hand side. Lastly is oxygen atoms. This is 2 times 3, you'll get 6. 3 times 2, you'll get 6. That means the equation is balanced. Preparation of zinc chloride, we react zinc with hydrochloric acid. This is another example where we are reacting acid and metal. You still get a salt and hydrogen gas. So our salt that will be formed will be zinc chloride plus hydrogen gas. Once again, you check if it is balanced. We are having 1 atom of zinc, 1 atom of zinc on both sides, 1 atom of hydrogen, 2 atoms of hydrogen. So we balance, we put here 2 like that. So it will mean I have 2 atoms of hydrogen on the left, 2 atoms of hydrogen on the right of the equation, 2 atoms of chlorine on the left of the equation, 2 atoms of chlorine on the right of the equation. That means the equation is balanced. Lead nitrate, we prepare it by reaction between lead metal and nitric acid. Lead metal reacting with nitric acid, we shall get lead nitrate, lead nitrate, lead nitrate, aqueous, it will be in solution form, plus hydrogen gas. So this will be our 2 products. Don't forget to balance. So we balance by putting here 2. Lastly, preparation of lead chloride involves the reaction between lead and hydrochloric acid. So lead reacting with hydrochloric acid, we shall get lead chloride plus hydrogen gas. So don't forget to balance once again. So you check each atom. Lead atoms are one on the left, the right has 1. So lead is balanced. Check hydrogen atoms. Here I'm having 1 atom of hydrogen. Here I'm having 2 atoms of hydrogen. So I'll multiply this one by 2 like that. So I'll have 2 atoms of hydrogen on the left, 2 atoms of hydrogen on the right hand side. And then chlorine will be 2 atoms. This is now 2 atoms. So the equation is balanced. So now we are saying that these are just some of the salts: zinc nitrate, zinc chloride, lead nitrate, lead chloride, which are prepared by the reaction between an acid and a metal. We have quite a number of salts which can be prepared by the same method. So we have come to the end of our lesson. Remember, we have learned about reaction between an acid and a metal as a method of preparing salts. We have learned and said an acid reacts with a metal to produce a salt and hydrogen gas as the only product. So I want you to try to answer the following questions. Try and answer these questions to see if you have gotten the concept well. So these are the questions which I want you to look at. Questions. So our first question is as follows. The first question is why was excess zinc powder used? Why did we use excess zinc powder? Remember, we mentioned in our procedure and we saw a reason. You can try that. Second question is why was filtration necessary? Why was filtration necessary? We also mentioned it in the procedure. You should be able to answer that question. And then our last question is write balanced chemical equations for the following reactions. For the following reactions, try this. The first reaction is between magnesium and sulfuric acid. Try that one. It's a method of preparing salts. We're reacting magnesium metal and sulfuric acid, you'll get a salt. Then you also try this one, calcium and nitric acid. So try writing equations for these two reactions. They still fall under preparing salts by reacting an acid and a base. So we have come to the end of our lesson for today. I'll see you next time. Thank you.